Perfect. Well, I can see it on my monitor. It doesn't matter. Oh, there you go. Thank you so much for inviting me. I'm really honored to be here. OBSSR, and in my case in particular, SOBC, has made a real difference to our lab. So what I want to do today is to talk a little bit about exactly what we've been able to do using SOBC, the Science of Behavior Change funding. We're interested, as Tom said, and thank you for that introduction. Just my mom would have been proud. We've been interested in understanding cognitive biases, or the way that people process their world. One of the most reliable findings in the world of adult depression is that adults who are diagnosed with major depressive disorders essentially attend to negative aspects of their environment. They attend to negative material. They can't inhibit processing negative parts of their worlds. When they process this information, they can't expel that negative information from working memory. Cognitively, of course, that's rehearsal, and because it's negative material clinically, that looks like rumination to us. So what I want to do is to kind of set the background for our SOBC project, and then show you where we're going with that in our lab as well. So one question that I want to address is, how have people really studied this process of selective attention, or this negative bias? And typically it's using something called a dot probe task, or a visual attention task. It's very easy. Many of you have seen this before. It's on a computer screen showing pairs of faces of the same actor, one emotional, one not. The emotional faces are angry, sad, happy, and the faces are up. A trial looks like this. Well, so when the faces come off the screen, behind one face there's a dot. Participants simply need to say indicate whether the dot's behind the left or the right face. The face to which they're attending at the time makes them faster to see that particular face, so that we can infer attentional allocation from this task. So a fixation point, I'm sure you're all looking at that sad face. Another one, okay. And so what do depressed people look like? Well, depressed people very consistently show a bias towards attending to the sad face. There are dozens of these different paradigms. This one's nice because it actually makes depressed people faster to do something, which is something that you don't see every day. So we have depressed people attending, unable to inhibit the processing of those sad faces, okay? We know that it's related to difficulties in emotion regulation. You can imagine if you're always attending to negative material and unable to expel that material from your working memory, that's going to impair your ability to use positive memories or positive material to regulate mood. I'll show you that it plays a role in stress reactivity. Our question was, what's the role of this in depression? Is it a symptom, in which case it's not all that interesting, but might it be a risk factor, and might it be a target that we can use for intervention, or more important from my perspective, for prevention of the onset of the first episode? Well, how do you answer a question like that? For us, we decided that we would take a group of individuals who weren't yet depressed, but who we know were going to be depressed during the rest of my research lifetime, which is getting just shorter in every... What does that mean? So it means two things. It means choosing people with a family history of depression, where we know that children of depressed parents have a 40 to 50% likelihood of becoming depressed. And it means that we choose girls, because we know that the prevalence of depression is twice as high in women as in men. In fact, I'll tell you one thing now. We have been recruiting, in fact, we've done this. We've recruited 100 young 10 to 14-year-old girls whose mothers have recurrent episodes of depression, and a control group of 100 girls without a family history of depression. This isn't relevant for this particular talk, but we've been following these girls. And at this point, 60% of the daughters of depressed moms have now had an episode. And so we've been able to follow them and start to look at predictors of this. But today, for SOBC, we were interested in two things. One is, are these diagnostically clean? That is, these girls have not yet had any psychiatric disorder. Are they also characterized by the same kind of negative cognitive bias that depressed adults demonstrate? And second, and for the SOBC project, the question to us was, what are the neural mechanisms that underlie these biases, if they're there? So first, are they there? Well, I wouldn't be here if they weren't. So let me just show you what that looks like. If you take these never disordered daughters with a family history of depression and without a family history of depression, and you give them that same dot probe task, what you see, and this is, for reasons we can discuss later, we put every one of these girls into a negative mood before we administered this task. So under a negative mood, daughters without a family history are attending to the happy faces. That's where their attention automatically goes. No matter how sad you make them, that's what they look like. In contrast, the daughters of the depressed moms look exactly like depressed adults, despite not having had an episode of depression themselves, okay? Given this, for this SOBC project, we wanted to manipulate this attentional bias to see if we could reduce it, and I'll talk about how we do that. But more important, we wanted to look at neural changes from pre to post training, that is training to reduce this attentional bias. What are we seeing as a neural mechanism that might be responsible for this cognitive change, and are there clinical changes that accompany that? So today I'm going to do two things. This clock hasn't changed from 25, and I know I've talked for more than a minute or two, right? So Tom, I'm going to rely on you to just say done, okay, or close. So I want to present some data showing how we've been able to look at neural mechanisms underlying behavior change. And I'm going to end with, as Tom suggested, studies in which we've actually tried to alter the neural mechanisms directly. So let me start by showing you how we try to reduce this attention to negative stimuli in these young girls. And that is, we use something called attention bias training. It now has a reasonable history, almost more in the field of anxiety than in depression. But we're trying to train high-risk girls, a different sample, because we don't want to interfere with the original sample I told you about who are developing depression. We recruited a new sample, exactly the same, daughters of high-risk daughters with a mother with clinical recurrent depression and daughters without a family history. We're training half of them to attend away from sad faces, and I'll show you how we do that, and towards happy faces. We have another group, half of them 25, in which it's a sham control condition. So they see the dot probe task, but it's a perfectly counterbalanced dots half the time under emotional faces, half the time under neutral faces. So if you were going to train someone 6 times over 2 weeks, you give them a laptop, you give them this task to go home and practice for half an hour each time, where do you want to place the dot on this task in order to get them away from these sad images, right? So you want to get that dot away under the neutral face. When it's a positive image, you want to put that dot under the positive, right? And so they've been training to do that for 2 weeks in a control group with the counterbalance condition. So first, we also have been assessing stress reactivity, and more important for this, neural activity related to inhibiting negative material and neural mechanisms that we think are engaged in self-referential thinking, negative self-referential thinking or rumination, pre and post. So the first thing you need to see is that attention bias training changes attention bias. All right, well, perhaps not surprising. These are data. I know I can do this, but I think I'm going to change a slide. Oh, I'm not. So you can see that we're reducing negative bias, and we're more than anything. Do you remember what this was? So these are these daughters of depressed moms who have now had 2 weeks of attention bias training. And you may remember from like 3 minutes ago that they look just like the daughters of never disordered moms, which is to us kind of cool. So we're changing attentional bias, but that's not what's interesting. What's interesting is that 2 weeks before, 2 weeks after the training, we put them through a lab stressor. And what you find is that the training, compared to the sham training, is resulting in an increase in positive affect and a decrease of almost 6 beats a minute to a lab stressor. So we're reducing stress reactivity in these girls, and what's even cooler, it just gets cooler, is we measure cortisol during this stressor. So pre-post training, I'm going to show you the post-training session for the girls who received real training and the girls who received the sham condition, and there are 2 things I want you to see. One is we've reduced the slope of the cortisol onset. That is the initial court response. It's a stress hormone. It's what people secrete in response to stress. And attention bias training is not only reducing the reactivity, it's reducing the absolute level during the recovery period itself. Now, this is interesting to us because we went back to our original sample, as Tom knows, and despite my protestations, Owen Wolkowitz at UCSF said that we needed to look at telomeres. I'm sorry Alyssa wasn't able to be here. She's part of that research group. So telomeres first found in caretakers of Alzheimer's patients who have high levels of shorter telomeres are linked to greater stress. But these are 12-year-old girls, and yet these daughters of depressed mothers have shorter telomeres at 12 years of age than daughters of non-depressed telomeres. And more important for this presentation is that the daughters of the depressed mothers, that is the daughters with the short telomeres, also have an elevated cortisol response, consistent with this stress response. And what we're doing is making these, I know I'm mixing studies and I'm going to be mixing metaphors, but I'm going to speculate here. I think that what we're doing with attention bias training is making these high-risk girls look like girls with longer telomeres. That is, we're reducing this stress reactivity response. What about neural mechanisms? So we scan these girls pre and post. I'm sorry, even if I go 30 seconds over, it's worth it. We are, I want to say we're scanning all of the girls, and we're not. We're scanning the girls who don't have braces. And so I know that we have a select sample here, and we may have a brace effect, and I'm happy to discuss that. But these are for the non-brace girls. I'm going to show you all of the neural data with kids. So what we're interested in is what happens when they try to ignore negative stimuli in their environment? And this is a nice task because what it does is they're given a same different response set and vertical versus horizontal in their buildings, and these faces are neutral or fear. And so here, if they had a horizontal set, it would be to decide if the 2 stimuli are the same or different, and clearly the 2 buildings are different. But you can see that we could put fear faces up here, right? And we could see if they're able, what their neural activations are when they have distractors that are negative, when they try to ignore negative stimuli in their environment. So what does attention bias training do neurally? It's very cool. What it does is it decreases amygdala activation as they try to ignore sad faces, and it's related to the bias change, in fact. So the better they do on the task, the more pronounced this deactivation in amygdala. And you can see that they're also developing cognitive control, what I would see as cognitive control in kind of frontal cortical regions, also tied to training. In fact, hugely tied to the extent of training. 5 minutes, perfect. So this was really exciting for us. And what I want to do in the 5 minutes remaining is to show you 2 other studies that were offshoots of this, different populations, but we were so gratified with this notion of mechanisms. So I'm going to show you 2 studies in which we're doing similar things, looking at neural changes as a function of cognitive training. And then I want to show you some data where we're actually targeting the neural mechanisms themselves. So let me just go through these 2 quickly. We're conducting a study of interpretation bias training. We're changing interpretation biases in currently depressed adolescents. And you can see that we're getting clinical effects of training, but as important, we're getting nucleus accumbens response changes. They are showing stronger activations in the reward circuitry to happy faces from pre to post training with the positive training as opposed to the neutral sham training. We have a study with depressed adults where we're training them to remove negative information from working memory. That training is reducing depressive symptoms. It's actually, as we would expect, reducing rumination. It's also, though, showing an effect on dorsal ACC. What they're doing is it's taking, we think, less cognitive control for them after training to eliminate negative material from working memory. These are all interesting neural mechanisms of the behavior change. I want to end, though, with what we're doing to target these neural mechanisms directly. And so we have a group of young girls, these girls at high risk for depression, and we're training half of the non-braces girls to use neurofeedback. We put them in the scanner and we train them to reduce feedback in their Salience network, which turns out to be largely anterior insula. We give them feedback to do that, and they learn, and I'll show you that they learn. We also have a sham condition in which the girls see. So the way we do this is we show them a negative picture and we show them a thermometer and we tell them just make the thermometer go down as they look at the picture. And girls learn to reduce activation in anterior insula because we isolate that area, we localize that area. And 12-year-old girls can learn very quickly to reduce activation in Salience network in response to negative stimuli. If you don't get real feedback, you can't learn a thing. There's no way you can do it. But they believe that they're doing it, which is another interesting story because we got strategies from them. But here's the cool thing. Before and after, I want to show you 2 weeks before training, 2 weeks after training, what happens. We gave them the dot probe task. This is post-training, real neurofeedback. We increase their bias to positive faces, okay? They look just like the girls who got attention bias training, completely different girls, by the way. In the lab, we're finding similar effects that we found with attention bias training. We're finding an increase in positive affect. We're finding a decrease in heart rate to a stressor. We're also finding that we're just starting to analyze the cortisol data, but it's also looking very similar. So I'm going to wrap up, and I'm going to say we're so grateful to OBSSR, to SOBC for moving the lab in this direction of mechanisms and targets. It's made a huge difference to grad students are now interested in what we're doing, and postdocs kind of come in every day. And so you see that for our attentional bias training, we're finding decreased reactivity and increased cognitive control. The first study with high-risk kids, right, or high-risk populations to demonstrate neural mechanisms underlying cognitive training effects. It's highlighting for us the importance of stress reactivity in depression, in kids at risk for depression, and was important, of course, for us in addressing the SOBC mandate. And as you saw, we're following all of these kids. We're looking at the effects of this training on longer-term clinical outcome. The initial data are promising. It looks like we're at least delaying onset of depression, and we're looking at what happens when you have longer training involved in this. And we're looking at neurofeedback in other structures. You can, I'm sure as you were thinking of this, saying, what if we did nucleus accumbens, right? What if we did reward circuitry? So we're doing different kinds of neurofeedback and looking at the specificity of that to RDoC constructs. So I'm gonna conclude, of course, postdocs, grad students, the lab has been terrific, but most important, NIMH funding, we just could not have done this without you. So Tom, thank you, and thank you all.